Hey guys, this is the High School Scientist and this is a follow-up to my previous video in which I explained the concept of vectors and the way in which you can add two vectors. So in this video, I'll try to explain the concept of vectors in 3 dimensions, aka the Cartesian coordinate system. But before that, let's learn about subtraction of two vectors. Yeah, I should have explained this in my previous video along with the addition of two vectors, but I ran out of time. So yeah, let's get started. Here we have two vectors a and b. Now it's not possible to subtract them because both of them are positive. But why does it matter? Like, even though they are positive, we should be able to subtract them just like we added them. Actually no, because remember, a vector has both magnitude and direction. So we can subtract the magnitude just like we did in the addition problem, but subtracting the direction would require us to do some extra steps. Okay, like just take a look at this diagram. Now if I subtract b from a, then this wouldn't be possible unless b itself is negative. Like if an angle A increases from its initial position, it means that something was added to A. But if the angle decreases, only then it would mean that something was subtracted from it. So this vector A should be moving in this direction if it's being subtracted. Okay, let's just take a look at an example. Here we have two vectors, vector A, which has a magnitude of 5 units, and vector B, which has a magnitude of 7 units. So we have to find the difference between these two vectors, A minus B, which we can also write it as A plus negative of B. And this is what I was trying to explain from the past 2 minutes. So now it's just simple as adding them, but instead of using cos theta, we have to use cos 180 minus theta, because there is an exact difference of 180 degrees between B and negative B. But still, this doesn't make any difference because cos 180 minus theta is just negative cos theta. In conclusion, the formula is just the same as adding two vectors, but in some places we replace the positive sign with the negative sign. That's it. So now we know how to add and subtract vectors. We can finally learn about vectors in 3 dimensions. Okay, so in your earlier classes, you would have learned that a point can be represented with a coordinate. Like we say that the point is some units far from x and y axis. So just like that, we can also represent vectors using coordinates, aka the Cartesian coordinate system. In my previous video, I told you guys that some of the questions that you might have to solve in your exams won't have diagrams to represent vectors, instead they would have coordinates. This is because math is math and people like to use less space to represent the same thing, even if it makes it complicated to understand. But this is only for a while. When you get used to the concept of vectors, you would find this to be much easier. So yeah, now we know how to add and subtract two vectors. But now we are going to learn the same thing all over again, because this time we will be using coordinates and not diagrams. So here we have two vectors and they are represented as coordinates. This is the magnitude and this is a unit vector, which is basically just a direction of a vector. Now if you note that both of them can be added without dealing with any angles or diagrams, because the initial form is just enough to do all those things. Here the vector A is being represented using 3 magnitudes, where even if any one of them changes, the direction automatically changes according to it. It's like the Cartesian coordinate system has in itself a built-in way of describing the direction. Not so hard after all, huh? The things that look and feel hard might actually be easier than you have anticipated. So don't learn a subject with the mindset of it being hard or complicated. Just look at it as something that you haven't learned before. So yeah, that's it for this video. We will take a look at cross product and dot product of two vectors in the next video. So yeah, this is the High School Scientist signing off.